Okay, so thank you, Andreas, and to everyone who is joining us for this risky session. So what I'm going to talk about today is socially embedded risk-taking, together with a couple of other people at UQ. And it will be a fairly standard plain vanilla experimental presentation in terms of first providing some motivation, provide a bit of discussion about the design and our hypotheses, the results, and a bit of discussion within, of course, the time limit. So just giving a bit of a flavor, really, of what is going on. This is work in progress. We don't yet have a paper. If you are interested in a paper, just drop me an email and we'll send you a copy of the paper when it's available. Thank you. So let me provide some, let me begin by providing some motivation. The standard way of thinking about decision making.
Sorry to interrupt, but maybe you can try the full screen mode. That will be visible better.
If you want to, it's fine. Do you see it? That's full screen. Yeah. Okay. What is normally the case in thinking about decision making under risk is very much as an individual decision. So if you take a decision whether to engage in entrepreneurial activity or not, or whether to, in the age of COVID, wear your face mask or not, or whether to buy a bit of toilet paper, it is very much seen an individual decision in a traditional economic perspective. Now, what I would argue, and what we would argue, is that instead decisions to take risk and insure are deeply embedded social decisions, and they are social decisions in ways that do not just depend on if you want, on potential incentives that would, in any case, induce interconnectedness. Because, of course, for example, you could potentially think about a toilet paper run on a supermarket being a bit of a bank run. So there have been a bit of a relationship, which is not just in terms of individual risk-taking, but which could be potentially rational when you take into account the behavior of others. What we're claiming is, however, that really there is something here deeper about the interdependence of risk-taking and insurance taking, which is there independently of financial, direct financial or other kind of private utility considerations. And there are plenty of examples, anecdotal examples that one can bring of that. I have provided 3 in this particular slide. There are plenty of others. Think about, for example, binge drinking as being another example of some stock market behavior. Now, per se, the fact that risk-taking has got an element of social interdependence is actually something for which there is already quite a large literature. Now, this literature is fairly differentiated in what it claims. It uses very different design. Some of it is neuroeconomic, some of it is behavioral, or most of it is just behavioral experiments. Most of it is with university students, some is not with university students. It's quite a large literature. Now, the bits of the literature, I guess, that would be most relevant as far as we're concerned, really relates to decisions that are made in a particular social group. There are a couple of papers of that which I particularly highlight on this slide that are perhaps kind of a bit more related to ours than some of the other work. But I guess one implication of the social interdependence of risk-taking should be in the way in which groups behave in their risk-taking and in the social risk-taking. So one of the things we're going to look at is if we provide a social anchor for risk-taking, and you're going to see what we mean about social anchor in a second, are people going to follow it? To what extent will it affect the ecosystem? Will social group feedback lead to actual learning dynamic that comes from the fact that if you invest more, I may invest more, and vice versa? And perhaps most interestingly, insofar as this contribution, there is something that we label as social group culture. And the idea of social group culture is that if my investment is a function of that, say of past investment in the group, and that is true for everyone else, an average, then what you should observe is that investment within a group or risk-taking within a group gets socially clustered, gets clustered together a bit more. So if I see you wearing a mask, I'm more likely to wear a mask. And in a sense, in a group, if you observe how much face masks are worn in a particular group, you will find that there is greater frequency of face mask taking in a consistent way than if you did not have a group. So we are going to see whether effectively you've got social group culture endogenously developing from the dynamic interaction. So our workhorse type of risk-taking task is a pretty straightforward Gnesian-Potter's risk mitigation task, which I actually originally used myself before it was Gnesian-Potter's in a pretty old paper as well. And it's basically a very simple task. You've got a pie. You decide how much of the pie you wish to invest in a lottery. And it's a factually more than actually fair lottery. So 50% chance of getting triple the amount, 50% chance of receiving zero if you lose the lottery. And so, of course, the degree to which you invest is a degree of your risk-taking up to, of course, potentially risk neutrality. This is all based on the standard stylized facts that most people in experimental environments are risk averse. And that will also be the case in our experiment. Okay, so let's think about what are experimental treatments. And I'm going to explain this a bit more, what they mean, the different dimensions in a moment with a couple of screenshots from the experiment. We had a 2x2 factorial design in which we either have low social prompts or high social prompts. You're going to see what these are in a moment, but effectively social prompts were prompts towards low investment or prompts of low risk-taking, and high social prompts were prompts of high risk-taking. So that's L vis-a-vis H. And then we had another dimension, which was the presence or the absence of social group feedback. So with social group feedback, so L and H. Without social group feedback, L, no social information, L and SI. High, no social information, H and SI. People played in fixed groups of 5 participants in the treatments in which there were social, there were social groups in particular, which was the L and H treatments, and they were repeated. They repeated the task 10 times, and yeah, the rest is fairly straightforward. Okay. So let me first of all explain you then what people saw, just to make this a bit more concrete then. So we had the prompts as coming from pilot sessions in which people effectively just played, Knizia Potter's tasks with no social dimension whatsoever. We collect a lot of data, and some of those observations, some of those investments were low observations, were low investment decisions, and we used them as prompts in the low prompts treatment. So we stated that the prompts were along the lines of, in a previous session, the participants invested 10, 10, 20, 25. This is out of 90, so these were pretty low risk taking. And so this was provided at the beginning of the experiment and only at the beginning of the experiment, so the beginning of the first period out of 10. And then people just chose how much they wanted to invest out of 90.
So Daniel, this 10, 10, 20, 25, these are hypothetical or actual?
No, they actually had happened. They had actually happened in the previous pilot session. So by running sufficient number of previous sessions, of people, basically, we managed to get symmetrical, low prompts and high prompts. These were symmetrical, but they did genuinely correspond to previous observations. So there wasn't, in that sense, there was no sense. So high prompts, 75, 80, 90, 90, symmetrical in terms of high levels of investment in a similar way. And then that is how we implemented the following periods. So when there was group feedback, this was pretty much provided using the same format. But now what people saw, say in period 2, was what everyone else in the group, remember there were groups of 5, chose in the previous period. So, and they were simply ordered by lowest to highest on the screen. Right? And then they had to make a choice, and they did this up to the 10th round. If there was no group feedback, instead they had no feedback. They just were just asked to state how much they wanted to invest in the lottery. Importantly, they did not know the outcome of the lottery as they went along, so there was no feedback in that sense about outcomes. So we kind of isolated out that dimension. Okay, so these are just pretty straightforward experimental procedure. I won't focus on that. Let me move on straight to the results. So first of all, do we have social independence of investment in the social groups treatments? The answer is yes, we did. Yes, we do. This was just a plain vanilla model, an average investment as a function of participants' investment, in which there is a positive relationship with the other average investment lagged. We have done other type of models that if there were time, I would go over. I can go over in the discussion section. But basically, variance and the Begonian-Suitens imitation model that looks effectively at the dynamic and how the dynamic evolves based on the behavior of the others in the previous period. But let me provide the screens visually, which is rather easier given the time. So okay, so this is the period on the horizontal axis, and the vertical axis you've got the mean investment between 0 and 90. So you will see that the high when there is a high prompt, you start off an average start off with about a little over 60. And then it pretty much stays stable. There isn't really much happening here. If instead you start off with a low prompt, that's low, initially, you start off with a clearly lower level of investment that is statistically significant. And then it doesn't really significantly increase actually when there is no social feedback but it does increase an average up to around 60 when there is social feedback, and that interaction is actually statistically significant. Okay, so there is evidence of social anchoring, and there is evidence of a feedback loop taking place in the L treatment, the low treatment. Now, however, there is an important point to make. This may give you the idea that potentially there's some kind of magic number that people converge in terms of average investment, 60 investment, but it actually hides what is a very substantial level of heterogeneity within. So if this is just the different groups in the different treatments, you're going to see that they are very, very different. There is a lot of heterogeneity across groups. That's a really important point. There's an enormous amount of heterogeneity across groups. So we should avoid sort of facile conclusions that there is just this magical 60 type of number. So what about testing for social culture? Well, what we do is that, well, there are no groups in, in the treatments without social feedback, but we kind of create through a computer simulation. What we effectively do, I won't go into the details now, but what we effectively do is that we create simulated groups. So we created simulated groups, and then we're able to see what is the dynamic or what happens in the simulated groups relative to the actual group in H and L. And specifically, we compare the simulated group standard deviation with the actual standard deviation in H and L, where our prediction there is that there should be a lower standard deviation in H and L than there is in when you use simulated groups. And that's the idea of social group culture. And that is actually what we find. This is perhaps easiest to see if you look at the right-hand side graph, although the same picture comes if you disaggregate it by the corresponding treatments. So what you have here on the vertical axis is the standard deviation on investment. LNH is the dotted red-brown line, and blue is the simulated group's standard deviation. And what you're going to see is that consistently, while there tends to be a bit of a drift up in any case of standard deviation, remember the social anchor is only at the beginning. Nevertheless, consistently, what we observe is lower standard deviation when there is social feedback and social glue, therefore bringing everyone more together than when there aren't social groups.
Then you have about 2 minutes.
Overall, if we provide a social anchor for risk taking, will people follow it? The answer is yes. There is a clear evidence that is the case. Will the effect be persistent? Well, to some degree, and it's clear that that is only to some degree that it is the case. That's also emerging to some extent from the upward trend here. Will social group feedback lead to social learning? Well, where there is dynamic, the evidence is that that is the case. And does a social group culture by which investment gets fostered by group? The answer is yes. With social group culture implies that if you are in a group in which there tends to be a high investment, high risk taking, high entrepreneurship, you're likely to be more entrepreneurial. If you're in a group that is more on the safe side, you also tend to play a bit more on the safe side, and that leads to effective endogenous emergence of social group culture. Thank you.
Thank you. Anyone, any questions for Daniel? Please shoot.
Yes, so Daniel, I have a question. So in group feedback, you shows the prompt each person by. So you have a group of five participants, and you shows individually what they invested, and then ask for the fifth participant's contribution. So do you think the results will change if we use like the average group participation?
Well, it's an interesting question for future research, really. In a sense, this type of result, in a sense, our test is a harsher test because in principle, people may, I mean, the effect of group culture, I would imagine, would be smaller in a situation where you can actually, for example, see whether there is a distribution all over the place, or whether maybe there is at least one person who doesn't care and just proceeds in their own way, etc. So in a sense, ours is a harsher test than of the emergence of social group culture than if you just provided an average value. But I agree, it would be an interesting avenue for future research. Thank you.
Anyone else? A question for Daniel?
So if not, I have one more question. So you use Gnisi Potter as a risk elicitation method here. So again, like my paper is on elicitation of risk methods only, so that's why I'm asking. Like using general risk scale or Holt and Lowry, do you think there would be difference, or would it be interesting to test these results in those setups?
Well, I mean, what can I say? Certainly, you could potentially use other methods. I mean, I think that Holt and one issue of Holt and Lowry is that, in a sense, you you've got a finite number of choices of options, right? So it's a less fine-grained way to measure risk aversion. And secondly, in a sense, you have to make multiple choices in a way, right? You have to make multiple choices. So I find rather more natural instead just to ask for a single choice, right? And basically, how much you want to invest into this. So I guess for this particular question, I would find it a more natural benchmark to use. Having said that, there is certainly a bit of there have been papers in the literature which I had on a slide at the beginning, which have used different elicitation methods like various MPL, Holt and Lowry, etc. I think there are some questions that can be asked with respect to that, but there have been papers that have tried to do that. And if you drop me an email, I'm currently in the process of writing a companion paper, actually a paper that comes before this one, and that paper actually will provide a bit of a review of this literature. So if you drop me an email, I can send it to you.
Sure.
Thank you, Daniel. I think we have to wrap it up here because
thank you, and thanks for the question, for the points. And answer to any other point by email. Thank you.
Very good. Xuting,
yes.
You are next. Are you ready?
Yes, I'm ready. Should I start now?
It's 12:24. Let's wait for a few seconds.
Okay.
We have been admonished to start exactly on time, just in case someone wants to join us.
No problem.
And you know that you have 20 minutes, and then there will be a few minutes of questions. It's 12:25 according to my clock. please take it away.
Okay, cool. Thank you very much. And thanks for giving me this chance to present my work with my supervisor, Agnieszka Timula. The title is The Increased Risk-Taking, Not Loss Tolerance, Drives Adolescents' Propensity to Gamble More Under the Peer Observation. So let me start with the motivation. Adolescents are notorious for their engagement in a range of activities that cost significantly to our society. For example, probably we often see or hear news that reporting widespread underage drinking or teenagers use drugs and so on. Now, one of the consequences of these activities is that the morbidity and the mortality rates of teenagers are 2 to 3 times as high as younger children. Among all other reasons, unintentional injury, which is mostly attributed to wrong decisions, is the biggest cause of death and hospitalization. Now, such behaviors does not only occur under the individual scenario, but also under some social context. Probably the most recent example is that adolescents, among all other age groups, is the main section that violates the social distancing rules or recommendation. When they get interviewed, they respond like, if I get corona, I get corona. At the end of the day, I'm not gonna let it stop me from partying. Now, such welfare decreasing behaviors seem to be exacerbated in the presence of peers. In Gartner and Steinberg's seminal study in 2005, they found that teenagers are more likely to crash when observed by peers in a driving simulator game. And this is also the case in the real life. Zimmerman finds that teenagers are more likely to be involved with car accidents when they drive with their friends sitting in the same car. In addition, teenagers choose to gamble more, become less likely to wait for larger rewards, and show diminished cognitive control to positive social cues under observation. Now, these seminal studies in psychology help us to start to understand adolescents' behaviors in the presence of peers. However, it is impossible to tell whether the observed effects are driven by a change in risk preferences, time preferences, loss aversion, and so on. For example, Smith et al. Found that adolescents are more likely to play mixed game and loss gamble when they believed they are being watched by another adolescent. However, since they only use the mixed game and loss gamble, it is not clear whether this is due to they become less loss averse or they become more risk-taking or even other factors. Now, 2 recent studies in behavioral economics start to fill in this gap. In 2019, Timula found that the presence of peers makes adolescents more impatient, but does not affect their risk attitudes or ambiguity attitudes in the domain of gains. Now, I emphasize the domain of gains because in this study, Timula only used the lottery options that involve with positive outcomes. Also in the domain of gains, another study that is done by Timula and the Whitechair, they found that older adolescents are less likely to choose gambles with unknown odds of winning over a sure amount under observation, but there is no effect in the likelihood of choosing gambles with known odds of winning. However, we note that even though the studies about adolescents' behaviors in the presence of peers are mostly motivated by the negative consequence of their choices, the existing studies predominantly focus on the domain of gains. In this paper, we focus on losses. We estimate adolescents' risk attitude in the domain of gains and the domain of losses, and also their loss aversion under observation and in private. We investigate such wide age of adolescents because we want to explore whether age plays a role in this context. Moreover, our experiment allows us to conduct both within subject and between subject comparison, which we believe that may contribute to the discussion that Charles et al. Proposed in 2012 about which method researchers should consider to use. Now, let me start our experimental design. 146 adolescents participate in our experiment. Among them, 12 to 17 years old participants are recruited using advertisements posted on Facebook and Instagram, and 18 to 24 years old participants are recruited using ORC at the University of Sydney. To elicit risky attitude and loss aversion, we use 120 lottery choices, which is a subset question from Sokol, Hansel et al. 2013 paper. Now, participants need to make decisions between a sure option and a 50-50 lottery option. In pure gain trials, both sure option and lottery options involve with positive outcomes only, and in pure loss trials, all options involve with negative outcomes only. Based on the decisions from gain trials and loss trials, we could estimate their risky attitude in the domain of gain and loss separately. In the mixed trials, the sure option is always $0, and the lottery option is consisted by 50% chance of winning an amount and 50% of losing an amount. Now, control for their risky attitude in the domain of gain and loss. Using their decisions from the mixed trials, we could estimate the loss aversion separately. Now, let's look at our experimental procedure. Upon arrival, participants are randomly allocated to be either a choice maker or an observer. After they read the instructions, they move to the observed stage. In this stage, one choice maker and one observer will be randomly paired together. And observers are instructed to move and sit next to their paired choice makers. When observers are ready, choice makers start to make 120 decision tasks. Now, to enhance the observer's attention during this observed stage, we design a test stage that I will explain in the next slide. Also, observers are not allowed to give instructions, to give suggestions to choice makers during the decision task. When choice makers finish, they move to the private stage, where observers are firstly asked to move back to their seat, and when everyone is ready, they make 120 decisions tasks. Now, for choice makers, they make 120 decision tasks again, but now without anybody observing them. To detect the effect of observation on preferences, we will focus on choice makers' decisions. We will compare choice makers' decisions made under observation to those made in private, which is also our within subject comparison. Now, you may be curious about how do we implement the observation. This is a sitting map that is simulating our experimental lab. Each cell represents a computer station, and each cross sign represents a participant's seat. In a private condition, to protect their privacy, participants are randomly allocated to seats with horizontally adjacent cubicles. But in the observed condition, in order to enhance the attention and also control for the physical distance between choice makers and observers, all chairs have been strapped together before the commencement of the experiment. To control, moreover, to make sure that choice makers only fail to be observed by his or her partner, only one pair out of 4 cubicles will be seated in a row. To control for the order effect, half of the participants start with the order 1 and the other half start with the order 2, where in this order, choice makers make their decisions in private first, and then they move to the observed stage. Similar to before, to detect the effect of observation, we will compare choice makers' decisions made in private versus made under observation. Now, because of these two orders, we could also conduct the between subject comparison. In this comparison, we will focus on the first set of choice makers' decision and compare the decisions made by choice makers from order 1, who made these decisions under observation, to the decisions made by choice makers from order 2, who made these decisions in private. And now let me finish the rest part of the experiment. After they finish the decision tasks, they move to the test stage. As I mentioned before, this test stage is designed to enhance observers' attention during observed stage. Now, before the commencement of observed stage, observers have been told that later in the experiment, 3 trials will be randomly selected from choice makers' question pools, and they are asked to recall their paired choice makers' decisions for the 3 trials. For each correct recalling, they will get an extra $1 in their final payment. Now, to equalize the payment scheme for choice makers, in the test stage, choice makers are asked to guess their paired observers' decisions for 3 randomly selected trials. For each correct guessing, they will get an extra $1 in the final payment. After the test stage, they move to the questionnaire, where we ask about some demographics and also their opinions about their partners. Lastly, the payment is consisted by 3 parts: $35 plus the outcome from one randomly selected decision, plus outcome from the test stage. Now note that if the selected decision is from pure loss trials, the maximum possible loss is $24, which is covered by $35 they start with, and therefore no participant will leave this experiment with paying from their own pocket. Now, to estimate their risk preference, we use two ways. The first way is the descriptive measurement, and it is constructed as the proportion of risky choices selected in each type of trials. But this descriptive measurement is not proper to estimate the loss aversion, and therefore we also conduct a structural model-based analysis. Now, in this presentation, I will focus on presenting the results obtained using structural model analysis, but for your information that the results for risk preference is similar using both descriptive measurement and the structural model-based. To estimate the utility of each option, we use a power utility function, where for a given outcome x, the utility will be x to the power of alpha g minus 1 in the domain of gain, and minus lambda times negative x to the power of 1 minus alpha L in the domain of loss. And then when alpha is greater than 0, it indicates risk seeking. When it's smaller than 0, it indicates risk averse. When lambda is greater than 1, it indicates loss aversion. Now, to detect the effect of observation on the preference, we replace the utility function with the linear combination in the domain of gains, as you can see here. The observed here is an indicator variable, which takes a value of 1 when the decisions are from observed condition, and takes the value of 0 when the decisions are from the private conditions. The linear combination for the risky attitude in the loss and the loss aversion are similar, as you can see here. Okay, now let me present the results, starting with some preliminary results. Here, I'd like to firstly convince you that participants understand the task. We ask 3 comprehension questions before the commencement of decision task. Only 9 out of 146 participants incorrectly answer more than 1 comprehension questions. In addition, we regress participants' choices against the lottery amount and the safe amount, and we found that they choose lottery options more often when the expected profit of lottery is getting higher, and they choose the safe option more often when the safe option is more attractive. So based on these 2 pieces of evidence, we conclude our participants do understand the task. Secondly, the observation implementation works in our experiment. So firstly, this graph shows you the average number of correct answers in the test stage. On average, choice makers could get correctly 2 out of 3 questions, but observers could answer correctly 2.3 out of 3 questions, which is significantly better than choice makers' performance. And this is consistent with observers paying attention to the choice makers' decision. Moreover, choice makers subjectively fail to be observed during the experiment. When we ask choice makers what proportion of your choices did the person observing you pay attention to, 93.33% of choice makers observed that they failed to be observed for at least half of their decisions. And now let's focus on the effect of observation. Here, I plot the proportion of risky choices made under observation on the horizontal axis and the proportion of risky choices made in private on the vertical axis. Each dot represents 1 participant scenario, and this red line represents the 45-degree line. Now, if participants do not change their decisions at all under both conditions, the dots should be on the 45-degree line. If they choose more risky choices under observation, the dots will be below the 45-degree line. Oppositely, the dots will be above the 45-degree line. And from this graph, we see that more participants choose more risky choices under observation. And now we're going to feed our data into the utility function to see if there is any effect of observation. Now, when pulling all data together, the significance level of the coefficient before the observed will tell us whether there is an effect of observation. And what we found here is that participants become more risk tolerant in the gains under observation, but there is no significant effect for risk tolerance in losses or loss aversion. And next, we explore whether age plays a role in this context. So going back to the previous scatter plot, but now I'm adding one more dimension, the age. So the blue dots here represent the participants who are 12 to 17 years old, and the red dots represent the 18 to 24 years old. And we see a very interesting trend that older adolescents systematically choose more risky options under observation. Now, this is proved in our structural estimation as well. After we controlled for the ages, no matter it's in the continuous format or as an indicator variable, we find that participants are now become more risk tolerant in gains and losses, and also more loss averse. And this finding still holds after we control for gender and wealth. But if we only control for gender and wealth, the result is similar as what we found before when we don't add any controls. Now, the effect of observation only reveals itself after we control for age, and the age becomes significant after we control for treatment, suggests that age of our participants may modulate the effect of observation, and therefore we decided to investigate more about the age variable. So firstly, we plot the proportion of risky choices made under observation and in private by age. Pulling all choices together, we can see there is no systematic trend for 12 to 17 years old participants, but for 18 to 24 years old participants, they systematically choose more risky choices. And this finding still holds when we look at the three types of trials separately. Now, because of this, we construct an indicator variable, 12 to 17 years old, to classify our participants into two groups. And then we draw the similar graph by this indicator variable. And as we expect, 18 to 24 years old participants significantly choose more risky choices under observation compared to the in private. When we conduct this structural estimation separately for 12 to 17 years old and 18 to 24 years old, we reconfirm our previous finding. Older adolescents become more risk tolerant in gains and losses, and more loss averse under observation. Moreover, this effect is substantial. For example, in the domain of gains, under observation, 18 to 24 years old, for 18 to 24 years old participants, the CRRA utility curvature will increase by 0.51. Even though so far we attribute the reaction to the treatment to age, not only age distinguishes these two groups in our sample. The former group is still attending high school, and the latter group is now attending university. And therefore, we investigate whether other factors rather than age also distinguish between this group in all of the variables that we connected in our questionnaire. And we find that more younger adolescents report have seen and met their partners before. They also assess their partners to be richer, even though there is no significant difference when they assess their own wealth level. And also more younger adolescents report to be less focused, but more consistent in their decisions under observation. And therefore, we check if the familiarity score, the wealth difference, and the consistency in choice may mediate the effect of observation on the preference that we have found before, but we don't find anything there. Last but not least, I'd like to show you the findings that we obtained using within subject versus between subject comparison. So far, all the results I have shown to you using the within subject comparison, which is indicated by these two arrows. Now I'm going to show you the results that we obtained using the between subject comparison. Firstly, we note that both methods yield similar results. Using the between subject comparison, we still find that older adolescents become more risk tolerant in the domain of gains and losses and more loss averse under observation. However, we note that the effect size is different. The effect is much more significant and also bigger when we use the between subject comparison. Especially for the risk tolerance in the loss domain and the loss aversion, the effect is 2.6 and 3.3 times larger when we use the between subject comparison. To conclude, in this paper, one finds that older adolescents become more risk tolerant in the domain of gains and the domain of losses, and more loss averse under observation. Now, our finding about loss aversion is striking. When we think about adolescents' behavior in the presence of peers, probably it's tempting to think that when they make decisions in the presence of peers, they make worse decisions because they ignore or they pay less attention to the negative consequence of their choices. However, what we find here is totally the opposite. Older adolescents actually put more weight to the negative outcomes. To argue this, we think that one implication of this finding is that probably we can emphasize more about the negative consequence of their choices when we think about some policy interventions that help adolescents make better decisions under the observation or in the presence of peers. Moreover, and in our study, the within subject and between subject comparison yield similar results, even though the effect size is different. We believe our project is inspiring for future studies about how to incorporate both methods into one experimental design to take advantage of both methods. And last but not least, we find an interesting but also very puzzling age dichotomy in the effect of observation on the preference. We explore whether other factors that also distinguish between these two age groups rather than age may mediate the effect of observation. However, we don't find anything in this paper, but we do believe that this finding needs more future research to really look at the mechanism behind this finding. And that is all my presentation. Thank you very much.
Thank you, Xuting. You're run slightly over time, but there's a couple of minutes left for questions if anyone has questions.
Sorry, can I just ask one question, I guess?
Go ahead, Daniel.
Thank you. So interesting paper. One thing I missed was how you recruited your sample. I'm just wondering, there may be sample selections, you know, between the way that you recruited, say, 21 years old and the way that, say, you recruited 13 years old. And this might perhaps be one source of difference.
The difference, yeah, that's what we are.
Selection biases, basically, yeah.
Yeah. So first of all, for 12 to 17 years old, these students are still attending high school. So we use the advertisements posted on Facebook and Instagram to recruit them. For 18 to 24 years old participants, they are all university students, and we recruited them using the ORC at the University of Sydney. We totally agree with you that there may be, because of this different recruitment strategy, this may create the difference between these two age groups, and maybe that's something that is driving the difference that we the result we're finding here. We try to explore this using the variables we collected in the questionnaire to see if any other factors may differentiate these two age groups can explain our results, but unfortunately we didn't find something there. But this does not conclude that there is this is not the reason. It's probably because of some other dimension that we didn't collect the data in our questionnaire. So I don't have answer for that.
And it would be useful potentially to maybe look at the continuum rather than just the dichotomy. Because I mean, you know, if 17 years old, how do 17 years old behave relative to 18?
From 18, exactly. Yes, that's definitely, yeah. Perfect, thanks for that question.
Very good. We have time for one more question. If there's no question, then thanks, Xuting, for your presentation. And Satarupa, please load up your slides.
Yes. Yes, thank you everyone for being present here for the talk. So this work
just let's wait for a minute. It's 12:49 here, and Okay, here we go. Satarupa is next. She calls in from Bangalore. Please take it away.
Thank you. So thank you everyone again for joining this. And this work that I am presenting today is a joint work with Professor Ritvik Banerjee at Indian Institute of Management, Bangalore, and Professor K.C. Adana at Christ University, with PhD student Priyoma Mustafi in University of Pittsburgh. So a brief outline of how we proceed about the talk is: first, we will talk about motivation and introduction, experimental design, analysis, results, conclusion. So starting with, so this paper actually builds on the study of the paper of Domen et al. In 2011, which is like highly cited paper. They show that the answer to the general risk attitude question predict actual behavior in lottery-based experiment for risk preference elicitation quite well. So they kind of try to suggest that risk attitude can be interchangeably used for risk preferences. So by risk attitude, they use a survey-based measures, and we will go in the details of those measures shortly. And risk preference are lottery-based incentive compatible measures. So with an experimental setup, we revisit their results and advance the finding of their results. Basically, the individual perception of risk attitude may predict the actual behavior on risky choices. This paper investigate the consistency in human risk behavior for risk preference and risk attitude. So what we mean by first risk attitude. So risk attitude is when I ask you, how do you rate yourself as a risk-taking person in a scale of 0 to 10, where 0 means not willing to take risk at all and 10 means very willing to take risk. By risk preference, we mean that there is an underlying incentive as a lottery-based method where there is an underlying utility function. So for example, what we are trying to do here is, suppose you give me 2 on a scale of in a scale of 0 to 10 of general risk question. So with that 2, I should be able to map you to either in the category of risk averse, risk neutral, or risk loving. And how we do that, we will talk about it. So for the analysis, we also try to predict the expected investment amount in the investment game of Gnizzi-Potters for each scale point of general risk. For the analysis, we use here multi-normal Rogers model and interval regression. So coming to the experiment design. So experimental design here is quite simple. We don't have any treatments or as such. We just ask the participants about 2 questions, the risk attitude and their risk preference. So data collected here is in a lab setup from a pool of 551 undergraduate students in Christ University, Bangalore, India. So for risk attitude, the question that asked to the participants is, how do you see yourself? Are you generally a person who is fully prepared to take risk, or do you try to avoid taking risk? Please tick a box on the scale where 0 means you are not willing to take risk at all and 10 means you are very willing to take risk. For risk preference, as already said, this is a lottery-based incentive compatible measures. So we use the widely used measure of risk preference, that is Halton-Lorry game. So I will quickly revisit the Halton-Lorry game here. So in Halton-Lorry game, the subjects are faced with 10 decisions in a row. So for each decisions, the person has to choose between option A and option B. Now, few things to highlight here are, option A is considered to be a safe option. And why is that? Because here, with some probability, you earn 200 mohars. Mohars is our experimental currency unit, or 160. So the variability is low here. In option B, whereas with some chance, you earn 385 mohar, and with some chance, you earn 10 mohar. So the variability is high here. So option A is what is considered to be a safe option, and option B to be a risky option. Now the second thing to highlight in a Halton-Lorry game is, as we move down the decisions that lie ahead, we see that the probability of winning the higher amount keeps on increasing in both option A and option B. So a person who understands these games correctly, there would be a point where the person make this series of decision and they switch from option A to option B. For example, in decision 10, there is 100% chance that a person earns 200 more, and there is 10% chance that a person earns 385 more. So even the least risk-averse person, if the person understands the game correctly, would switch here to option B. So now this Holt and Lowry uses the switch points to derive their risk preference classification. One more thing is, suppose you have a very high risk appetite and you switch at decision 3. Then what is the total number of safe option that you choose is 2. So this total safe we use as a one of our outcome variable. Okay, so how Holt and Lowry uses this switch point to come to the risk preference classification. So I won't derive it, but we will just show this table is directly derived from the Holt and Lowry's paper. So Holt and Lowry shows that if your total number of safe choices is 2, you lie within this range of relative risk aversion, and you are classified as a very risk-loving person. And so it goes on, and this suggests that if your total number of safe choices is either 9 or 10, it's better you stay in bed. A quick revisit of the Gnizzi-Porter's game, although Daniel explained it in his presentation, I would explain it in terms of our experimental parameters. So in our setup, in the beginning, each participant receives an endowment of 100 mohors, and they are asked to invest something in between 0 to 100. So a success will multiply the invested amount by 3 and plus what you didn't invest, and a failure would turn your investment amount into 0 and you are left with what you didn't invest with. So for example, out of 100 you invest 40 mohor. Heads, you earn the 60, the amount that you didn't invest, plus 3 into the 40, that is your total payoff is 180. And tails, you earn only the amount that you are left with only the amount that you didn't invest. Okay, so before proceeding further, we want to, since we are drawing a parallel with Doman's paper, we want to fact check a few things, what they have in their paper. First, talk about the summary statistics. So general risk scale is 5, total safe is also 5. People all on an average invest 58 mohors, 58.75 mohors in the Gnizzi-Porter's game. The proportion of female is almost 52%. This graph shows the distribution of general risk. So on the x-axis, we have the general risk scale and the frequencies in the y-axis. So again, this graph is what we get very similar to the distribution what Doman shows in their paper. We also show a gender-based distribution. So for breaking the convention here, the males are represented by pink and females are represented by blue. And you can easily see that the distribution for male is more skewed to the higher general risk scale values, which again reconfirms the fact that female are more risk averse than their male counterparts. Come to the determinants of general risk. We see that only the gender matters in determining the general risk. The other demographic factors like age, 10th marks, 12th marks, major of the subject, family income, religion, caste, they don't matter. The age don't matter seems a little bit counterintuitive, but since our subject pool is undergraduate student, we don't have much variation in age, or we don't have older people in our subject pool. Now we show the risk attitude in different contexts. So beside eliciting the general risk attitude in a scale of 0 to 10, we also go to the subcategories. Like, how do you consider yourself to be risk-taking in case of driving, in case of financial risk, in case of sports and labor, when it comes to your career. And all those shows a positive correlation with the general risk. So this again, a result is very similar to the Doman's paper. Now coming to the model description. As I stated earlier, we use a multinomial logic model. So before you get overwhelmed with all this equation, simply what we try to do here is, on the dependent variable side, we have these three categories: risk averse, risk neutral, risk loving. On the explanatory variable, we have the scales of general risk. So we use the scales of general risk 0, 1, 2, 3, 4 up to 10 to predict the risk averse, the probability of you being risk averse, neutral, and risk loving. So we club all these three together as a risk loving category. We club risk neutral and slightly risk averse as risk averse category, risk neutral category, and risk averse, very risk averse, highly risk averse, and stay in bed as risk averse category. Now coming to the results. So first a little overview. So females are more risk averse than their male counterparts, which we saw to the distribution of the graph. The correlation between general risk attitude and the total safe, that is risk preference, is minus 0.26. So this means higher you mark yourself on a general risk scale, the lesser is the amount of total safe option you choose in a Holton-Lowry game. So first two findings actually confirms the findings of Doman et al. Now, in an attempt to take it further to map the general risk to the risk preferences, we find that individuals who consider themselves very less risk-taking on risk attitude is predicted to have significant non-zero probability of being risk lover based on their lottery choices, that is risk preference. Also, a simple investment game like Gnizzi Potters predict reasonably. The expected amount increases with the increase in general risk scale. So this is the main highlight of the paper. So these are the predictions from the multinomial logic model. So how do we read this graph? So talking about the first graph. So if you choose 2 on a general risk scale, this graph shows that the probability of you being risk averse is somewhere between 0.6 or 0.7. Okay. Similarly, if you choose 4 or 5 in a general risk scale, the probability of you being risk neutral is somewhere between 0.2 or 0.3. Similarly, if you choose 8 or 9 on a general risk scale, the probability of you being risk loving is somewhere between, is more than 5, like 0.6 or 0.7. So at the first glance, it all seems fine. Like so these points add up to 1. So this plus this adds up to 1. So at first glance, this all seems fine. That when we are talking about probability of risk averse, the highest probability or higher probability is given by lower scale on general risk. When we talking about risk neutrality, we get a flat range and high range around 3, 4, 5, 6. When we talk about risk loving, the highest probability is given by the later scales, that is 7, 8, 9 of risk loving. But the thing is, also here we see that someone who says they are 8 on a general risk scale, they have significant non-zero probability of being risk averse. Okay. Similarly, someone who says they are 3 on a general risk scale, that is they mark themselves lower on their risk attitude, have again a significant non-zero probability of being risk loving when it comes to their lottery choices. Next result is from the Gnizzi Potter's experiment. So on y-axis, we have the expected amount of investment, and x-axis again, we have the general risk scale. So first few, we have a little bit of inconsistency, but after a point, like after 3, we see as the people mark themselves higher on a general risk scale, they invest more in a risk Gnizzi Potter's game. Okay, so finally, to the conclusion, we study the possibility of mapping 2 methods of risk elicitation. Broadly, the survey-based methods of general risk attitude and the incentive-compatible lottery-based methods. First, we re-establish the previous findings of Doman's paper, that there is a significant correlation between the self-reported general risk attitude and lottery-based methods of risk elicitation. However, we cannot significantly assign each scale of risk response to a specific risk preference classification. That what we started with, we say you give me a scale that you are 3 on a general risk scale, I will tell you that either you are a risk-loving person or a risk-neutral person or a risk-averse person, but we cannot distinguish it. So this result brings us back to the debate of survey-based and incentive-compatible risk elicitation method. So from this study, at least we can suggest that they are not perfectly substitute for each other. They have their own importance. So yeah, thank you for your attention. Questions?
Yes, we have plenty of time for questions or comments. Daniel, go ahead, please.
Thank you. So just, I guess, a couple of points that I missed from your presentation. I may have just been inattentive at the time. So first of all, did you randomize the order of the task across subjects, or did you have a fixed order? That's my, I guess, first question.
Randomize the order, you means like asking the risk attitude question first and then asking the risk elicitation question second?
Yeah. So for example, Alton Lowry first or attained, etc. So how did you,
No, I think we don't order that. We first, like, we ask them to play the Halton Lowry game, and then we ask them in a survey based question, and we ask them about this risk attitude and risk preferences. So
just because I guess potentially there might be spillover effects from one task to the other, particularly given that they all relate about risk. So I guess just something worthwhile thinking about.
Okay. Yeah, sure. So I think we have enough gap between the two, but yeah, that I will certainly note and check once again that how, if there is spillover effect or if we can negate the spillover effect with whatever we have already.
And did you, so again, just for clarification, I mean, yes. I assume you incentivize the Halton Lowry and the Gnesian Potters?
Yes, so they are paid randomly for one of the rounds.
So in a sense, there were two differences between the Doman questionnaires and the behavioral questionnaires. One was that one were questionnaire, the other were behavioral. That the difference was that one was incentivized, the other was not incentivized. So I'm just wondering, in a sense, that may be something that potentially, again, may needed to be taken into account in the interpretation, I guess, of your results.
Okay. Can you repeat that again? I'm not sure if I get it.
Well, sure. So so the Doman questionnaire, it's a questionnaire. Okay?
Yes. Yeah.
They take instead Gnesian Potters. Gnesian Potters is a specific behavioral task.
True.
And it is also an incentivized task. Okay, so you pay you pay based on the outcome of it. So I guess what I'm stating, I'm not saying this is a big deal necessarily. Yeah. But what I'm stating is that there are two things that change between the two then. One thing is the fact that you pay in one task, you don't pay in the other task, right? Yeah. You don't comment, just a question after all.
So again, like in we pay randomly between either Halton Lowry or Gnesi Potters.
Sure, precisely. So they are incentivized. That's my point.
Yeah.
So there are two things that change. One is the fact that the behavioral tasks are incentivized. And the other fact is the fact that, of course, they are those specific behavioral tasks.
Okay. True.
Yeah. Just something worthwhile bearing in mind in terms of interpretation.
Yeah, sure.
Andreas, is there time for one more question? Andreas? Sorry.
Yeah, Jane, go ahead.
Oh, okay. So out of curiosity, do the two incentivized tasks map well into each other? The Hotlori and the Ganesi Potter?
I think we have run the that analysis, but I don't have the slides for it yet. But yes, they map well to each other.
Okay, so I guess my impression from the literature is that incentivized tasks don't necessarily map well to each other either in terms of, you know, choices that would suggest that a
Yes,
person
we
is
have not
extrovert.
run an elaborate analysis for that, but I think the correlations are positive. So yeah, maybe we can.
Sure. I guess my point is in the conclusion you had stated that, you know, we cannot replace sort of survey-based, or we replace the incentivized tasks with survey-based measures.
Yes.
But in a way, we can't do that either, even with incentivized tasks.
Okay, I get your point. Yeah.
Yeah, so just a matter of sort of how to talk about the conclusion.
Yeah, that's a good point. Okay. Okay, thank you.
Yeah, it's 1:15 here in Sydney, and it's time to come to the last presentation in the Risk and Uncertainty 1 session. When we submitted our project, it sounded like a good idea because we'd done a couple of pilots in our physical lab. Because of developments in Victoria, we had to stop doing this, and we ultimately decided to go online for good, which meant further programming, further pilots, further ethics modification requests, and whatnot. We have at this point done more than half a dozen pilots. We still have to do a couple of them next week, which is one way of saying I won't present any data today. I will just present the design implementation of what we intend to do. When I talk about we, it's Philip Fidanowski. This is actually Philip's dissertation project, one of his dissertation projects. And after I made a couple of introductory remarks, he will take over for the remainder of the talk. The third author on this piece is Julia Dixit, who may or may not join us today. As you know, risk preferences rarely manifest themselves clearly. Their quantification requires elicitation and structural econometric estimation. Scholars have tried for a long time to extract the true risk attitudes by employing various approaches which are listed there. We try in this current project to extract latent risk preferences by employing elicitation methods that are typically used in the lab. Now, to fix terminology, when we talk about context invariance, we talk about consistency. When we talk about time invariance, we talk about stability. We'll focus today on consistency. There's quite some confusion about the meaning of the word context in this literature. In our terminology, context is a more comprehensive term that covers domains. Two domains, of course, referring to particular subsets of contexts, finance, transportation, health, sport, recreation, and whatnot. Now, when we started this project, we went out first and did a really intense literature review, which for the most part means Philip did much of this work. And it turns out there's more than 100 ways of how to elicit latent risk preferences. That kind of surprised us all. The problem is that the results of different elicitation methods often differ and occasionally even contradict. To give you one example of many recent studies, Pedroni et al. In 2017 observed that only 6% of the subjects display identical risk preferences across revealed elicitation methods. Now there's obviously a challenge. The challenge is to compare existing elicitation methods in a comprehensive manner, and that's what our project is really about. Now we have tried to select elicitation methods along main classifications such as state and revealed. preference elicitation, simple or complex, dynamic or static, and how exactly that has been motivated. Philip will explain now to you with a wonderful table that he will explain. Philip, take it from here.
Thanks, Andreas. Good order from me. On this slide, we can see the acronyms. In the rows, we can see the acronyms of the elicitation methods that are tested in the context. And in the columns are the number of studies. That is how it is motivated and what is done before, based on the extensive literature review, where we can position ourselves on the graph. The first method that we have chosen is the MPL or the whole dowry. That we have chosen this method because it's a popular elicitation method. It is already used in the dominant part of the context consistency literature. The second method that we have chosen is HEORM or random pair lottery design. 4 studies are examining the whole HEORM in the context. Portfolio choice task is examined just in 1 study by Dan Friedman, and bomb risk elicitation task is examined unconfronted with other elicitation methods in 5 studies. There is no comparison so far as far as we know. To best of our knowledge, there is no comparison between Holt-Lowry and HEORM. There is no also comparison between HEORM and bomb risk elicitation task. And finally, there is no comparison between random pair lottery design and PC. And PC is not compared with bomb risk elicitation task. In addition to this, random compound lotteries, dynamic estimation of economic preferences, and portfolio choice in 2 stages are not compared to any other elicitation method. The risk case, that is the final elicitation method in our project, is compared to the elicitation method, but not with the reviewed. In addition to this, the previous studies, the comparisons that have been made were afflicted by problematic design, different implementation choices, questionable methods. For instance, most of these studies are using the linear correlation, but there are serious problems in terms of linear correlation or Pearson coefficient, because that is not implying causal relationship, but the problem is most visible if we are talking about the whole dowry, because that could be subject of nonlinear affine transformation, which implies that the correlation coefficient between elicitation methods can still be 0 when these methods are nonlinearly related. Also, there are experiments on elicitation methods that are not incentivized, they are underpowered, and the challenge that is imposed is that we have to provide robust elicitation of the latent risk preferences across different elicitation methods. We are considering the temporal stability and domains in our follow-up study, but now I will strict my attention to the context consistency. How we have decided for this battery of elicitation methods, in addition to the graph that I presented, we have decided in favor of this because they allow structural estimation of the risk parameters, provide a nice balance between cognitive load and precise estimation of the risk, that they are incentive compatible. More important, that they meet our criteria for domain flexibility. That is, as I mentioned, that is our follow-up project, and most of them have not been compared before. They are from various groups. As I said, we will use random pair lottery design because this is because of its remarkable structure of flexibility, multiple price lists, as Anderson and Miller are saying that this is the gold standard in the experimental literature. Random compound lotteries as dynamic equivalent to the RLP. Deep because it's a remarkable computational efficiency. This is the first time that the method from adaptive group is tested in the context. And there are 4,000 of combinations in the 12 questions for this elicitation method. The risk staircase is simple and visible, as well as the portfolio choice. And the portfolio choice in 2 stages is just dynamic equivalent to the PC. And finally, bomb risk elicitation task, because it is simple and it has an increasing popularity. On top of this, we also include 2 stated elicitation methods. One is the DOSPERT, because it is one of the most representative method, and questions from the socioeconomic panel risk attitude, because it is simple and flexible. And finally, we are assessing the subject's understanding of the risk by using the Berlin numeracy test, cognitive ability by employing cognitive reflection task, and exit surveys contains various questions regarding socio-demographic background, state and life events of the subjects, and general information that are important for our study. The experiment is lasting less than 3 hours. We will pay one round from each of the elicitation method, randomly chosen, and 5 fixed or flat fee for the stated elicitation methods and service. The experiment, as Andreas mentioned, originally three pilots were conducted in the laboratory, but now we have moved to Z3 Unleashed. The design is within subject design originally, and we are controlling for the order effects of the various elicitation methods based on their groups. Criteria for recruiting of the subjects are that they are registered on the ORCID database, that they are, and the second criteria is important, that they are enrolled in the first or second year of their undergraduate studies, because in order to reduce the possible attrition for the retest session, that they have very good English language skills, that they have attended less than 5 experiments in the BIS lab to eliminate the spillover effects from the other experiments, and other things that are helping us to conduct this in the online environment, to have PID account, personal computer, internet, Zoom, and to want to share with us audio and video. The programming is done in Z3. The minimal guaranteed payment is 10 Australian dollars, average is 50, and the maximum is 100. There is no foreseeable risk. The confidentiality is preserved. Ethics approval is granted. As Andreas mentioned, also we have submitted modification request, and that is also approved. We have conducted 4 pilot sessions in the virtual machine in the Z3 Unleashed, in addition to 3 in the laboratory, so altogether 7. We have not analyzed the data. Why? Because we want to pre-register this. The main hypothesis and experimental data will be pre-registered and stored at the Open Science Framework in order to avoid carking. We have also prepared the power analysis. But you can see that there is a heterogeneity based of the Cohen's F-square coefficient. There is a heterogeneity. The median is 0.052 of the various studies, which means that it is very small. Cohen's F2 is a local effect size based on the multivariate regression models. We were able to compute just for 34 comparable studies. We have also corrected this for. We have used this information, the median effect size. Then we have corrected the power by Shida correction and the power of 0.80, and you can see that we have to recruit 242 participants. In addition to this, because there's heterogeneity in the studies, we have decided to use as a benchmark the Renato Frey paper that is comparable, that is using 7 elicitation methods, that is considering the retest session, and in that case we have to recruit 110 participants, we multiply by 2, and we control for the attrition of 10%, and it is altogether 240. Importantly, we make a clear distinction between unconditional and conditional consistency of the risk preference estimates. That means that unconditional consistency means that the risk preference estimates obtained from various elicitation methods are same or identical across elicitation methods, whereas conditional consistency implies that the risk preference estimates are dependent upon relevant state or socio-demographic determinants. That means, for instance, expansion of the family and some illness in the family and so on. We are, in terms of the contribution, in addition to what we have mentioned, we are observing the level of convergence and detecting potential differences between elicitation methods. We are observing the choice behavior in the stated and reviewed elicitation methods, which means that we are testing the hypothetical bias. And finally, we are also observing dynamic consistency of subjects in dynamic elicitation methods, which is strategically an equivalent context, Rokel axiom, and dominated choice and multiple switching behavior for 3 elicitation methods. In terms of the methodology, we are using both non-parametric and parametric analysis. Non-parametric analysis will help us to assess the features of the elicitation methods, what is their implication and relevance and the magnitude. And also the standard parametric analysis by considering the behavioral error, noise from the observed data. And as far as I know, 2 working papers updated are now updated for implementing the obviously related instrumental variables. That is one of the most advanced methods in the last period for context consistency. In addition to this, we are considering, as I mentioned, the consistency and stability by using the distance correlation that is counting for the nonlinearities, and we are providing the robustness checks by implementing specification curve analysis. Finally, in terms of the methodology, we are classifying the subjects in dynamic elicitation methods by myopic. That are the subjects that completely ignore the second stage, naive that are choosing the best direction or decision as viewed from present perspective. Resolute subjects are not changing their initial choice in the first stage, and sophisticated are using the backward induction for their choices. Multiple switching behavior is also considered by dropping inconsistent observation, counting the number of safe choices, and logistic regression to estimate switching points. So three different strategies that are done, but just for one elicitation method, not compared before. And now Andreas will say a couple of words in terms of concluding remarks.
So you can see there's quite a lot of work to be done. We have run enough pilots to be confident that we can do this and that we can do it within 3 hours for pretty much all subjects, somewhat to our own surprise. But I have a couple of questions about this later for you. Concluding remarks, we study the consistency of latent risk preference across context. It's also a baseline actually for us to study later the stability of risk preferences. And of course, it's also kind of a baseline for us to study consistency across domains. We analyze the dynamic and logical consistency, as Philip said. We analyze the noise specification effect, risk preference estimates, which utility model and parametric specification fit best or later. We analyze the existence of hypothetical bias. We study the effects of social-demographic and personal characteristics, state and life events for risk preference estimates across context. Of course, there's various extensions. I already mentioned stability of risk preferences, which we haven't talked about here a lot. We can do cross-validation with beta analytical coefficients, and those are probably the 2 key things that we have. So thank you everyone for listening. We have a couple of questions for you. If you don't have any questions for us, please shoot if you have questions. I don't think anyone has questions here, for all I can tell. Then let us pose a couple of questions that we have for you. We would be grateful if you think that we missed anything in our design. If there's one particular citation method that you think we should maybe switch in or switch out. We have pretty good rationalization for the 8 revealed elicitation methods and the 2 stated methods. But we're always happy to hear comments or suggestions. The second question is, right now it's within subject design, which can take up to 3 hours, as mentioned. It's kind of unusual. Also people, for example, in Berlin and Basel have done experiments that lasted even longer. Our own experience is that in the Zoom environment, where we watch people, they work in a very focused manner, possibly more focused than they work in the lab, which came as a surprise to us. So the second question is, within design or between design? And finally, the last question for you is, we intend to pay one instantiation of each of the 8 revealed elicitation methods. Shall we go to paying only one of the 8? We would love to hear your comments. Daniel.
Yeah, I mean, the between subject vis-a-vis within subject, in a way, it's an interesting one. I think that in part it really depends what is it that you want to prioritize in terms of objectives of your study, because I mean, from the brief overview you have done, it seems to be a big agenda with a lot of things that you're actually looking at. So obviously, if you're interested in the within subject consistency in some kind, then obviously, well, you have to do it within subject in one way or another, right? I mean, you know, that's just the way it is. So there could be ways of potentially ameliorating issues of potential direct spillover, but they would be complicated. So if you just had 2 methods, for example, if you want to specifically make a particular robustness test involving 2 methods, maybe pre-selected according to a preliminary study like the one you're doing, then you could, for example, have one method done together with some stuff in a first session, and then you ask people to do, and they're paid only at the end of a second session, which is say 1 or 2 weeks later, together with other stuff. And then by doing that, you can have the other measure in there covered with other tasks, so that the objective of the experiment is not too obvious. And so you would avoid, and you could of course then counterbalance that. But the key point is that by having 1 week difference, you would avoid any issues about people becoming too tired, or issues about spillover effects from one task to another, etc. But you can't, it's very hard to do that obviously with 8 different methods, right? So, you know, that could really only be possible on a subsample, if maybe as a robustness test that you could do, you know, in case someone were worried about that.
And if you pair it with other tasks, then of course there's also the potential for spillover effects of various kinds that we might not want.
True. Well, I was more thinking about potential filler tasks, and you could always have this at the beginning as the first task.
Yeah. Would give that some thought. Anyone else? Any comments? Then I suggest then I first thank everyone for listening in to all 4 presentations today. I suggest we wrap it up at this point. Everyone gives themselves a round of applause, and I trust we see each other maybe at some other presentations at the ESA Global 2020 meetings.